Good morning, kids. Today's class will discuss about the oblique projectile motion. It's a very important topic. There are plenty of JEE Advanced, JEE Mains questions every year they were asking. So we'll start with the assumption. So let there be a ground. Let's make ground. So from the ground, I'll project a ball. You can take this to be ball, stone, anything that one. So I'll project with a speed u at an angle theta. This everything is a ground. Will write it. How the trajectory of the ball will be? So the ball will move in a parabolic path. Again, it will strike the ground at some distance. Then, so what is this particular path? This will be the path of trajectory. So how the trajectory will move? It is going to move in a parabolic path. This particular thing is called as parabolic. Why parabolic path? All we are going to create suitable proof. Agreed. This one. Then here, when ball is projecting, what are the quantities that will be acting? So when you project a ball with a speed u, the weight mg will act. So how do I expect it to move? So it's going to move in a resultant path. What is this? This red color one is a path. So how the ball? The ball will be moving in this parabolic path. It will not move along the projected velocity. Get this one? So how do it move? The ball will move in a curved path. Why do it will be a curved path? Because under action of the weight, because of the velocity and the weight, the resultant path will be in this direction. Some curved path, let it be that one. So now, what about assumptions we are making? We are assuming that there is no acceleration along x-axis. And what about acceleration along y-axis? G. Why there is no acceleration? Because how the weight of the body will act. The weight of the body will act vertically down. So therefore, this weight, so how do we write here? Ay is equal to mg by m. So we will provide acceleration along y-axis, the weight. Get understand? So because of the velocity projected and because of the gravity acting, the resultant path will be a some curved path. This will be that one. Okay, there's a one basic idea. So why do it move in a curved path? There's a one basic background. So one must know that this information. This is something very important. Why it will move in a curved path? Okay, let's see that there's a why there is no acceleration along x-axis. Because how the weight will act? The weight will act vertically down. So naturally, there won't be any acceleration along x-axis. Getting this idea? No. We'll apply what is all this projectile motion. Projectile motion is all about the applying the equations of motion along x and along y. Along x and along y, we'll apply the equations of motion. That's what all the entire the projectile motion. So after some time, where the ball will be. So the ball will arrive here. Let me put a dot, like there's a ball projected from the ground. After some time, it will have horizontal component and vertical component, and it will definitely will ascend some height. Let me call y, and it will be at a horizontal distance x. At t equals 0, we have projected. At any time t, let it be here. And here it will have the velocity v. How the velocity v will be directed tangential to the path. And after some time, it will ascend to the highest point. So what about this? This particular thing, we'll call this as a highest point here. The ball will move in a curved path here. Call this is V2, here V3, V4, V5, and finally it will strike the ground with the same speed. Okay, this is about the path what we have to trace it out. Then let's come for one by one few quantities like this particular thing is called like a range. The maximum horizontal distance covered by the ball in the curved path is called like a range. So this will call this as a range, that one. So this is called as a range. Then afterwards, it is going to ascend a maximum height. Here, this one. It is going to ascend a maximum height in this entire trajectory. When it moves in this curved path, it is going to ascend at a maximum height. This will be maximum height. This particular thing, what we'll call this as like a maximum height ascended. H will call it. Then this distance will be r by 2. Then it will come back and it will come and strike the ground again after some time. Say at t equals 0 I projected. So it will move in a curved path. After some time again it will come and strike the ground. So this particular thing will become time of flight. After what time again it will return back to the ground. So that particular thing we'll call that as a time of flight here. So now we'll define all the quantities one by one. This is very important. Let me keep it here. Now let's write all the possible equations along x-axis. Equations of motion. So then what we can write? X equal to u cos theta t. I'll write this ux t plus ax t square by 2. What is ux? What is x? What is u? Initial speed of projection. So what is this u? This is the initial speed of projection. What is this theta? Angle of projection. We'll define like this. Then what is the initial velocity along x-axis? The initial velocity along x-axis, we write it as u cos theta. Initial velocity along y-axis is u sin theta. Acceleration along x-axis is 0. Initial velocity along x-axis u cos theta. Let me substitute all those things here. Fine. After substituting that, we'll get this is u cos theta plus 0 t square by 2. This everything will become u cos theta into t. So this will give the one horizontal position of the particle. This is something very important. X equal to, I'll write down one. X equal to u cos theta t. So this will give the horizontal displacement of projectile or a ball at an instant of time t. This called like a path or trajectory. The ball is called as a projectile. We are giving one specific name. It can be any object. The particular ball is called as a projectile, that one. And the path traced by the projectile is called as a trajectory of projectile. Then along y-axis, we'll apply the equations of motion. So what was the velocity along y-axis, initial velocity along y-axis? We'll resolve here. U cos theta, u sin theta. You have to make observation here. Okay, fine. So what is the initial velocity along y-axis? It is u sin theta. At t equals 0, u sin theta. After some time, because of the retardation by the gravity. So what do you expect? How do this g is acting opposite to u sin theta? So what do you expect now? The particle initially will undergo retardation. So therefore, along y-axis, we'll write the equation. Along y-axis, y equal to uy t plus ay t square. Now substituting all the values, uy, u sine theta t, ay will be g, y negative sign. Why this particular negative sign for g? Look at this g, how it is acting. This ay is acting opposite to initial velocity u sine theta. And according to the convention, what we do, whenever acceleration is directed opposite to initial velocity, it should be taken negative. Okay, agree this? So there's one basic idea of y negative sign. So this is about the, now we'll substitute this, this another equation we have. We'll substitute equation 1 in 2. One in 2. Then this is the u sine theta x by u cos theta minus g by 2 p square will be x by u cos theta whole square. So this will be x tan theta minus gx square 2u square cos square theta. Now the equation what we had, this is the equation of the trajectory, what we can call it. So what is the name we'll give it? Equation of trajectory, or like a mathematical equation which will determine the path of the trajectory. It will move in a path. So how do this equation represents like a parabola, y equal to alpha x minus beta x square. So this equation of trajectory represents a parabolic equation. So therefore, what is the path of trajectory? Parabolic path. So therefore, for the projectile motion, what will be the path? The path will be a parabolic, this particular path. So how do the ball will move in a parabolic path. So this will be a parabolic path. The trajectory will be a parabolic. Like this is what we are giving a proof for this. Then how do practically will it move like this? This was the one primary question what we'll ask ourselves. We'll take example of this. There's a football. There's a football. Everyone is seeing this one. Let me round it off. Okay, this is the football where this person is going to kick it. There's a person. Then when this person kicks here, it will impart a velocity here. It will impart velocity. And at an angle theta, it will start moving. And this particular thing is a ground. I'll shade like this. This everything is a ground. Or else this everything is a ground. Fine. Now, what will happen to the football? How do it will move? The very first question comes like. So because of the kick imparted to it, it will acquire a velocity u and it starts moving. Then as it starts moving, what are the forces? The weight mg will act. So because of the weight mg and this velocity, it will start moving in a curved path. It will move like this. Next question comes up. What makes it again to move like this? Again, it will have velocity, say v1 and mg. So how did it should move? It is going to move in a path like this. Once again, I'll put it everything. Weight mg will act, and this will impart, and here velocity v1. So how the path will be? Because of the resultant of velocity and the weight, it will move in a curved path here. The same thing here. Because of velocity and weight, it will move in a curved path. Fine. So what is this? This particular dotted one, this will say path of football. What we are having is football. So everyone now getting the idea. Now this will produce an acceleration. What is acceleration along y-axis? Equal to g. There is no acceleration along x-axis. When the ball is moving, what are the forces? The force will act, only the weight will act here. So definitely it will undergo retardation. Then it will have two components. One v1x, other will be v1y. When it comes here, it will be say v2. Then here it will have velocity v3. Here it will come and strike the ground with the same speed u. Okay, now we'll analyze all these things. So what is horizontal component of velocity? Should remain same. How much of velocity here? U cos theta, u sin theta. What about velocity here? Will be u cos theta. The vertical component of velocity will keep on changing. This will become v1 sin theta. Here it will be horizontal component remains constant. Why horizontal component of velocity should remain constant? Because there is no acceleration along x-axis. There is no force acting on the ball along x-axis. Along x-axis, there is no force acting. That's why the horizontal component of velocity remains same. How much everywhere will be u cos theta, will be u cos theta, now also u cos theta, now also u cos theta. So again, how much we should write here? This should be equal to v3x, which is equal to u cos theta. Again, finally, u cos theta. Look at the horizontal component of velocity. It remains same. This is a very important part in the projectile motion. Then vertical component of velocity. Earlier it was u sin theta. Now it will become v1y or v1 sin theta. Now here it will become 0. Then here it will become v3y. Let me show that v3y. And again this will be u sin theta. So what will happen to the vertical component of velocity? Here u sin theta decreases, becomes 0, then increases. So if you can see in the football, so what is actually happening? v1y will be less than u sin theta. v3y less than u sin theta. Next you have to ask questions are like what will happen to this vertical component? Because of the weight mg, the vertical component of the projectile will keep on increasing. So when it moves from here to here, the vertical component decreases. It decreases. When it moves from here, highest point to the point of striking, it will decrease. So we'll give some name. This is the point of projection. This particular thing will call highest point. This is the point of striking. So what's happening to the projectile? When it moves from the point of projection to the highest point, horizontal component remains same. Vertical component will keep on decreases. Then when it moves from highest point to the point of striking, vertical component will keep on increase. Horizontal component remains constant. So this is what happens in the basically projectile motion. So based on that information, we are writing this basic data. Not only we'll take not only football, it can be even the golf ball also. So we'll write all the some data wise. This is the ball, golf ball. This is the point of projection. T equals 0, it will be here. So as the ball moves, when it arrives here, it will have v1x, v1y, and you have to draw a tangent that will give the to the path that will give the direction of velocity. You have to draw a tangent. The tangent will give the direction of velocity of the ball. After some time, the ball will be here. it will have v2x, v2y, and v2. Then at highest point, this will be the highest point. Here, what about the ball? It will have component, say v3. Only horizontal component it will be there. Fine. Then after some time, the ball will start descending. It will have velocity v4. I'll resolve it. v4x, v4y. This will be v5, v5x, v5y. And finally, to strike the ground with the same speed u. Okay, we'll analyze all these things. So what about this velocity? U cos theta, u cos theta. Horizontal component has to remain same. I'll choose some other color. U sin theta. So which component of velocity will be changing? The vertical component. So this will keep on decrease as the ball ascends. It will keep on decrease at highest point. Here it will become 0. Here it will have maximum velocity. How much maximum velocity at the point of projection? U sin theta. Look at this one. Maximum velocity is u sin theta. Now will become v1y, v2y. Here it will become 0. Then because of weight acting, then it will start increasing v4y, v5y, and so on. And finally, it will strike the ground again with the same speed. Let's write all the data. So what we have is u sin theta greater than v1y greater than v2y. Then u sin theta greater than v5y greater than v4y. So as the ball moves along y-axis, we can discuss here. The speed of the vertical component keeps on decreases, becomes 0. After, when it moves from point of projection to point highest point. From highest point to point of striking, the vertical component will keep on increase. And finally, the point of striking will become equal to initial velocity, what we have projected, u sin theta. Fine. What will be the horizontal component? The horizontal component has to remain same, because the reason for that, v1x will write this. v1x equal to v2x equal to v3x equal to v4x equal to v5x equal to u cos theta. What is the reason for all this? Acceleration along x-axis is 0. Fine. The horizontal component remains same. So this what happens in case of anything. It can be golf ball, it can be a projectile motion, it can be stone. You take a stone and project it. It can be, it's not only from football or some cannon. If a tank is there, there's an enemy tank. It will fire some bomb. So how do it will move in a parabolic path? Fine. So what is this? This will be shell, what we can call, or bomb or missile. This will be enemy tank, and this is a ground. What makes it to move like this? It is projected with a speed u and weight mg will act. Because of speed and the weight, it will move in a parabolic path. Okay, fine. So here it is projected with a speed u. Then because of the weight of the bomb, it will move in a parabolic path. This is what happens. Fine. So this is the idea. Parabolic path. So what all we are discussing, this is applicable for what? Anything up. Even you take a stone and project it. Even you take a stone and project it, how the stone will move in a parabolic path. So, sir, what is the theta where you are indicating? This is the theta. Then here also, it will have v1x, v1y, here v3, v2x, v2y, u. Okay, this will be theta. We'll assume that it is projected from the ground, not certain height. Fine. So this is what basically a student must have the projectile motion, and it'll be a parabolic path. The path will be a parabolic path. The path of the ball. So how the ball will move? Ball moves in parabolic path. Okay, fine. How the bomb will move? Again, the bomb will move in a parabolic path. Fine. So this is about one. Background is what you needed. Okay, let's go for this one. So something in this particular thing, I'll ask you, what is the, it will ascend some maximum height, no? It is at a maximum height from the ground. Range and the time of flight. At t equals 0, we have fired the bomb. After some time t, it will come and strike the ground. So definitely all these quantities I wanted them. So how you define the maximum height? Maximum height ascended by the projectile measured from the ground. How you define the range? The maximum horizontal distance of the point of striking from the point of projection. This is called like a point of striking. This is called like a point of projection. This is called like a highest point. So we'll define these quantities now. We'll write it. This is h. This particular distance, we'll call this as a range. And this is the time of flight. So how you define h? Maximum height. What about this? Horizontal range, or just we'll call range. And what is capital T? Capital T defined as time of flight. So now we'll try to derive an expression for all these quantities. First, we'll discuss one by one. So here, the acceleration due to gravity is acting here. First, we'll calculate the time taken. So when this particular ball from the on a point on a ground, when it moves like this, at t equals 0, it is projected up. It will move in a parabolic path. After what time, it will come and strike the ground. It is again coming and striking the ground, or this particular shell. Again, it will come and strike the ground. So this particular time is what we'll call as time of flight. At t equals 0, we have projected. So how to calculate this particular time of flight? When the ball moves, when this ball moves, from where it was projected t equals 0 on the ground, and where it will strike again on the ground only. So what is the displacement perpendicular to the ground? Is 0. So we'll select a displacement along y-axis equal to uy t. When the ball moves from the point of projection to point of striking, what is the displacement perpendicular to the ground? This particular thing is a ground. What is the displacement perpendicular to the ground? Plus h plus h. Okay, back to this one. Plus h, then minus h. No. So what is the net displacement? Will be 0. Fine. Now we'll write it here. Plus h minus h equal to u sine theta. What is the vertical component here? U sine theta. T. What is the acceleration along y-axis? It is g, no? And how do this g is acting opposite to this u sine theta? So therefore, we should take negative. There's a reason why you are having minus g of p square by 2. So this is equal to u sine theta minus, so what is the time of flight? 2u sine theta by g. This is the expression for time of flight. Next, similarly, we'll derive an expression for maximum height ascended. So this quantity will maximum height ascended. We have to derive expression for this. Fine. No. So when I'll consider again, when the ball moves from point of projection on the ground to the highest point, we'll call this as the highest point. We'll give name for this. I don't have place everything. I'll dumping at one point only. Visible. This particular thing is called a highest point. So when the ball moves from the point of striking to the highest point, what is the displacement? The displacement will be h. Then what is the vertical component here? Vertical component here is 0. No, there is no vertical component, only horizontal component. So vertical component will keep on decrease. Earlier u sine theta, now v1y, v2y, and it keeps on decreases, and finally it becomes 0. So we'll apply the equations of motion between point of striking to highest point. I don't have place, so let me use here only these things. Let me adjust. Okay, fine. Now we'll give some name A, B, and C. From A to B, we'll apply equations of motion. 0 square u sine theta whole square 2 minus g into plus h. Now you have to ask questions, sir, why you are writing this 0? At point B, what is the vertical component? 0. Okay, fine. Then at point A, what is the vertical component? U sine theta. Then how G is acting? Opposite to U sine theta. So negative. Why H is positive here? Because how you are measuring displacement, though it moves in a curved path, what is the displacement from A to B? We should take plus H, no? And how you are measuring this displacement in the direction of initial velocity. So therefore, this will be positive. Fine. Okay, now we'll simplify it. This will be u square sine square theta 2g8. So the maximum height ascended will be u square sine square theta by 2g. Already I defined them here. What is h means maximum height ascended. What is t means time of flight. Okay, we'll go for the next quantity, the horizontal range. For the range, what we do is, again from A to C. Because I need diagram and all the things, so screen will be of this much of size only. So there's no other choice. I'm dumping everything in one screen only. Now from A to C, we will discuss that one. So when the ball moves from point of projection to point of striking, how did it move? It moved in a curved path, a parabolic path. Fine. Then what is the horizontal distance it will cover? R. This R is what we'll call range. So we'll apply equations of motion along x-axis. R equal to ux v plus ax t square. S equal to ut plus half t square. Then range equal to, what is ux? This one, u cos theta. What is the time of flight? T 0 t square by 2. So this will be u cos theta 2u sin theta by g. So what is the range is equal to now? 2u square sin theta cos theta by g, or u square sin 2 theta by g. So this is the expression for the range of the projectile. Okay, fine. One more. So like this, all these equations we have derived it. Which you are supposed to remember all these things. This will be very, very important. Like this, so how we define now? This particular thing is called like a maximum height ascendant. This is called like a horizontal range, and the ball from point of projection to again the golf ball. No, you are going to place it on ground. When you hit it by that particular stick, it will move in a parabolic path. It will strike the ground. That at the point, the distance at which where it will strike the ground to the point of hitting, this particular thing is called like a range. This particular thing, we'll call this as a range. Agreed? And this particular thing we'll call the maximum height. Like this, we defined all these quantities. Okay, now we'll go for the next condition. Okay, once again, all these things will summarize one by one. So this particular thing is called like a maximum height ascendant. So what is the velocities will be? I think I have some. Okay, no. Look at here. The same football, that one. So this at t equals 0, we have projected it. After some time, t will come and strike the ground. We define this as a maximum range, maximum height ascendant. Then what about the range? This particular thing will become range. Agreed. This one. And this particular thing is time of flight. So because of the gravity is acting, gravity will act, and this is u cos theta. This is the initial projection. After some time, the velocity will be v1x, v1y, and v1. Here it will have velocity only u cos theta. I'm briefly summarizing everything. Then what makes the ball? And here it will have only weight. No, the weight is acting. The weight mg will act, and the horizontal component of velocity. So how do it will move in a curved path. It will not go straight. Why it will not go straight? Because of weight and velocity, it will move in a curved path. You just take some throw stone horizontally. How do it will move? It will move like this because of velocity and weight. The same condition here also. So how the trajectory will be at this particular point, it will be a curved path. Then again here, the weight mg will act. Because of weight mg acting, velocity will increase. And finally, it will strike the ground with the same speed, vertical component of speed with which it was projected. So this will be theta. This is a brief summary of things what we have discussed. Continuously the weight will be acting. This is very important. Continuously the weight, we don't think that only at highest point. Everywhere the weight will be acting. Because of weight and the velocity, it will move in a curved path. Because of weight and velocity, it will move in a curved path. Because of weight, velocity, curved path. Because of weight, velocity, it will curved path. Okay, yeah. Here also, because of the weight and the velocity, curved path. So there's a reason why it will move in a this curved or parabolic path. Like this, we have defined what is this projectile motion. So why acceleration along x-axis? Because the weight will act only vertically down. There is no force acting on the body along x-axis. That's why acceleration along x-axis 0. So when you kick the football, what type of motion described? Along horizontal direction, the velocity remains constant. Along y-axis, first it will undergo retardation, then acceleration. So what we should write here? It will be along A to B, we'll write it. A, B, C. A to B. A to B will be retardation along y-axis. Then constant velocity along x-axis. Then from A to B to C, acceleration, the same data. Acceleration along x-axis, along y-axis. So here the velocity keeps on increases. Then constant velocity again along the x-axis. Okay, there's one basic idea of the projectile. Everywhere will be using this condition. Nothing big is there. Okay, agree this. After this, we'll go for how to find out the speed of projectile at any instant of time t. Already we got the position vector. Speed of projectile at any instant of time t. So what is the speed of projectile will be along x-axis? It is, we'll find out here. Speed of projectile at any time t. This is given by v1x or vx equal to u cos theta. Let me use this data here. What about vy? U sine theta minus gt. I'm using this one. When it moves from here to here, horizontal component remains same. Vertical component decreases. Why decreases? Because this g will act opposite u sine theta. That's why we're having minus sign. Why this is positive? Because this vy will act. This vy will act in the direction of u sine theta. So therefore, this will be positive. Whereas g is acting opposite to u sine theta. That's why this is negative. This is positive. Okay, agreed. Okay, now we'll continue further. We'll find out the speed at any time t. No? So the v equal to vx square plus vy square. This is equal to u cos theta whole square sin square theta g square t square minus 2ug sin theta into t. Further simplifying, how do this has come? Expanding this one. Expanding this, we'll get this much. Okay, agreed? Now this will be Again, look at this one, u square cos square theta, u square sin square theta. This everything will be only u square plus g square t square 2u sin theta g into t. Like this, we'll get expression for speed of projectile at any time t. I think this was the thing which is asked. Okay, some very just we are applying equations of motion, nothing big is there. Afterwards, the position vector. The position vector means this one. I'll take it off this. This will be y. This will be x. The position vector we define like this. R bar. So how to get the position vector R bar, or what do that position vector will define the position of projectile at any time t. Which is given by xi cap plus y j cap. What is x equal to? U cos theta into t, u sin theta. Let me write on this, then I'll explain it. Sir, okay, what is this position vector? Sir, we are not under. Position vector means this one. No? This is a position vector. This is a path length. Path length is different than position vector. Fine. And what is this? Y position, Y coordinate. This will become the X coordinate. R bar will become position vector. So at what distance the projectile is from the ground at any time t. That we are defining it here. So this will become now like this. We can expand this. So there's a difference between the position vector and the path length in the projectile. Let me give a better explanation. So when we throw any ball, there's a ball, stone we have projected. It will move in a parabolic path. Fine. This will take it. You can see all the things clearly. After some time, at t equals 0, ball is projected from the ground. Agreed. Then at t equals 0, we are projected with a speed u at an angle theta. After some time, it will be here. Just wait. And I'll redraw it. The highest point not needed. Yeah. After some time, the ball will be here. We are projected with a speed u. Then what is that position vector? I will indicate here. Are you seeing the difference between the path length and this one? This is the path length. I'll indicate separately. Or you can see this. This is a path length. This particular thing is position vector. Hope everyone getting some idea that R bar is what we have derived. So what is that R bar you derived means? This R bar what we derived what all I derived, no? This R bar is this one. So what is there any difference between the path length? This one is a path length. This one is a position vector. Okay, then here we have two things. So then what is theta, sir? Theta is what with respect to the angle made by the velocity vector with horizontal. This is theta. Then this angle, what we call this angle, we'll call it as a angle of elevation. We'll define all the things. No? So what is theta? Theta will become angle of projection. What about phi is called as angle of elevation. How to define the angle of elevation? Again, the same formula. Tan pi is equal to y by x. What is y? U sine theta t minus gt square by 2. What about x? U cos theta into k. This will become tan theta minus gt by 2u cos theta. So there's a relation between the angle of elevation and angle of projection. Okay, this as usual maximum height. So we have defined the position vector, angle of elevation, this one. Next again, the distance of the projectile. The distance of projectile is time t from the point of projection is given by mod of r. This particular thing, this is called like a distance of the projectile. Means at what distance, at any time t, the projectile will be there. The ball or what you can say projectile will be there from the point of projection. This particular thing is what we'll call it as a distance. So already we know r bar vector. Modulus of this we have to take it. R bar is equal to, this will be u cos theta t whole square this will become distant position vector, distant. Okay, these are all the terms what we define for the projectile motion. Okay, kids. So this is the, so let me summarize the oblique projectile what we defined it here. let me take this diagram. The person will kick the football. So he will impart the velocity u in this direction. He will impart velocity u. He will impart the velocity u at an angle theta. Then how the ball, because of the weight and velocity, it will move in a parabolic path. Then again because of weight and velocity, again it will move in a parabolic path. There's one basic idea of why it will move in a parabolic path. Okay, fine. Then as it moves in parabolic path, the weight, what it will do? It will decrease this vertical component of velocity. Then what will happen to horizontal component? Horizontal component, there is no force acting along x-axis. There's no force acting along x-axis. There's no force acting along x-axis. So therefore, the horizontal component remains same. Then when it moves from A to B, vertical component decreases, horizontal component remains same. Then when it moves from highest point to the point of striking, what should happen to the horizontal component? Again, it remains same. Where the vertical component keeps on decreases. Or we'll take one small example. We'll take one small example. This again the same small example, the golf ball only. So here I'm projecting it. The ball is projected at t equal to 0. So what is the speed? The initial speed, let it be 10 meter per second. Let theta be 30 degrees. So what is the initial velocity? U cos theta 45 degrees, let me write it. And we are projected with a speed 10 root 2 meter per second. Then after some time, the ball, this velocity is how much will be? 10 meter per second. This velocity also will be 10 meter per second. Horizontal component, u cos theta, u sin theta. This will remain 10 meter per second only. What about this? This will become, say, 7 meter per second. After some time, this will remain as 10 meter. This will become, say, like a 2 meter per second. After some time, it will have only 10 meter per second. Then the ball, again from here, the weight will act. Why, sir? Why this one? Because of weight mg. Because of weight mg, the vertical component will keep on decreasing. Next, horizontal component remains same. The vertical component now will start increasing 3 meter per second. Then finally it will strike the ground with the same speed what we have projected, with the same angle. Hope everyone, this is something very important. Finally, projectile motion, you should know these things. The speed of projectile along x-axis will not change. Along y-axis, you can see that one, 10, then again here is 0. Let me write it here. Vy is 0. So look at this one, 10, 7, 2, 0. Again it starts increasing, 3, 8, again it becomes 10. So along y-axis, the vertical component will decrease, become 0, then increases. Along x-axis, it all the time remains constant. And what is this path? This path will be a parabolic path. Again and again I'm repeating. Then we define something, sir. What do you mean by position vector? We are not understanding. Position vector means this will be the position vector. You can define for anything. Then this will become r bar. Agreed? Then this will become y. This will become x. You can define for anything. Huh? Not only in this region, sir, we should discuss. Me not. Then it will have a speed v. This is one basic idea of the oblique projectile. Huh? Hoping everyone is able to understand. A lot of examples are given. You take a throne, you take a stone, throw it, or kick the football or the golf ball. All these are general examples of projectile motion, nothing to do that one. And what we are doing, we are applying equations of motion. Along x-axis and y-axis. So what is the projectile motion? This is a trick. for problem solving. For all our problem solving, we'll be using this one. Applying equations of motion along x, along y axis. Along x axis, acceleration 0. Okay, put ax equal 0. So our equations will be what? Like x equal to ux t plus ax t square. Y equal to uy t plus ay t square. Acceleration along x axis 0. So therefore, this will become uxt. Acceleration along y-axis will be non-zero. So what is all our entire problem solving will be using equations of motion along x and y. Before the projectile motion, again, don't think that something new concept you learn. No, the motion in one dimension only you have using twice along x, along y. That's what the projectile motion. Okay, coming class, okay, we'll discuss the still more conceptual things about the oblique projectile is there. We'll discuss that one. Okay, thank you for watching this video. I'll end up the class. Thanks, kids.